All right, let's dive in. Today, we're going to take a trip back in time and trace the absolutely incredible journey of data storage. We're going to see how we went from these giant, clunky magnetic reels to the tiny, lightning-fast flash drives that we all have in our pockets. It's an amazing story of technology shrinking in size while just exploding in speed.
You know, it's a question you've probably never even thought about. You finish a document, you edit a photo, you hit save. But where does it actually go? What's happening inside that machine to make sure it's there for you tomorrow? Well, the answer to that is a concept called secondary storage. It's basically the permanent memory for your entire digital life.
So, at its core, secondary storage is the forever home for your data. And the key term you're going to hear is non-volatile. Now, that's just a fancy way of saying the data stays put, even when you kill the power. This isn't like your computer's short-term memory, which forgets everything in a flash. Nope, this stuff is built to last.
Okay, so let's wind the clock all the way back. Our journey begins in the age of magnetism. Yeah, before we had lasers and silicon chips, the very first way we figured out how to store digital information was by using one of the most basic forces in nature.
And this, right here, is the granddaddy of them all, magnetic tape. Seriously, just think of a giant old-school cassette tape. It's a long plastic ribbon coated in magnetic stuff, and by magnetizing tiny little spots on this tape, we could represent the ones and zeros of computer data. And believe it or not, these things could hold a ton of information, which made them perfect for big institutions like governments and universities to archive everything.
But there was a huge catch, a massive drawback, and it was called serial access. To find one specific file, the machine had to physically read the tape from the very beginning, all the way through. It was exactly like trying to find your favorite song on a cassette. You had to sit there and just painfully fast forward past everything else. For everyday computing, this was just way, way too slow.
So, the solution to this whole speed problem was the first real revolution in storage, the hard disk drive, or HDD. Instead of a long, clumsy tape, the hard drive uses these spinning magnetic disks called platters. These platters are neatly organized into rings called tracks, which are then sliced up into smaller pieces called sectors. And the computer keeps a master map, basically a table of contents, that knows exactly which track and which sector every single piece of your file lives on.
And this, right here, was the absolute game changer. The move from serial to direct access. While the tape made you wait and wait, the read/write head on a hard drive could literally jump almost instantly to any spot on that spinning platter. The best way to think about it is like a vinyl record player. You just lift the needle and drop it right onto the song you want to hear. For computers, this changed absolutely everything.
So, magnetism gave us speed, but of course, the hunt was on for even more storage and even more precision. And that led to the next great leap forward. The next era wasn't going to be defined by magnetism, but by something even faster and way more focused, a tiny beam of light.
And this, of course, brings us to optical storage. So instead of magnetizing a surface, these devices use a laser to read these unbelievably tiny bumps and flat spots on a disk. They're called pits and lands. See, a pit reflects light just a little differently than a land, and that tiny, tiny difference is how the drive reads the digital ones and zeros. Pretty clever, right?
The first format to really take off was the good old compact disc, or CD. It used a red laser and could hold about 700 megabytes. Now that might not sound like much today, but back in the 90s, that was revolutionary for distributing music albums and computer software.
And then came the DVD, and wow, what a jump! All of a sudden, we could store around 4.7 gigabytes. The trick was actually pretty simple, but it was genius. It used a red laser, but with a shorter wavelength. A more focused beam meant you could make the pits and lands much, much smaller and pack them way tighter, finally giving us enough room for a whole movie.
And the final leap for optical discs was the Blu-ray. And as you can probably guess from the name, it uses an even shorter wavelength blue laser. This allowed for another massive jump in capacity to about 27 gigabytes on just a single layer disc. And that, finally, gave us enough space to store movies in glorious high definition.
Now, you've probably seen these letters on discs before, right? ROM, R, RW. Well, it's pretty simple. ROM means read-only, like a movie you buy. The data's on there permanently.
R means it's recordable, so you can burn your own data onto it, but only once. And RW means it's rewritable, so you can erase the disk and use it over and over again.
But, even super-focused lasers and spinning disks have physical limits. The next revolution, the one we are living in right now, is the most radical one yet. It's the solid-state revolution, and its big idea was to get rid of every single moving part.
And that's really the fundamental idea here. No more spinning platters, no more mechanical arms moving back and forth. Instead, data is stored completely silently by trapping electrons inside these incredibly complex silicon chips. It's not mechanical at all, it's pure electronics.
And when you put the two technologies side by side, the difference is just staggering. The solid-state drive, or SSD, has 0 moving parts. That means no delay, no waiting for a platter to spin up. It uses less power, it's way more durable because you can't break what doesn't move. And as you can see, that access time is in a completely different universe.
Let's just let that number sink in for a second. 0.1 milliseconds. Compared to about 10 milliseconds for a pretty good hard drive, an SSD is literally 100 times faster at finding your data. That incredible speed is the reason modern computers can boot up in the blink of an eye. It's a total game changer.
And this amazing technology, it's not just hiding inside your computer, it is everywhere. It's the exact same solid-state principle that powers the little USB pen drives we use to move files around, and the tiny memory cards inside our digital cameras, and of course, our smartphones.
So after this amazing journey from slow-moving magnetic tape all the way to instant flash memory, where do we stand today? Let's just take a quick snapshot of the current landscape.
Well, this brings us to right now, and the reality is the whole landscape has shifted. Optical discs like CDs and DVDs, they're pretty much obsolete. In fact, most new computers don't even have a drive for them anymore. Flash memory, like a USB stick, is the undisputed king for moving files around, while all our big stuff lives on either a massive hard drive or, more and more, on super-fast solid-state drives.
And that brings us to the future. We've gone from slow magnetic tape to instant access on a tiny silicon chip. But here's the thing. The amount of data we're creating is doubling roughly every 2 years. It's an exponential explosion of information. So the question we're left with is, what comes next? What revolutionary new technology are we going to have to invent to store the world of tomorrow? Thanks for watching.